We factor this trinomial by first pulling out the GCF, minus 2. So we have x squared minus 3x minus 10. And then we continue to factor out this trinomial. X times x is x squared. And what times what is 10? Let's try 5 and 2. And put a minus sign here and a plus sign here. Indeed, x squared plus 2x minus 5x is minus 3x. And these two numbers multiply to be negative 10. So this is the fully factored form. When factoring trinomials, we should always pull out the GCF. In this case, let's pull out 100. We have 2x squared plus 5x minus 12. And this here is a trinomial where the coefficient is not 1. We can try guessing or use the rainbow method. Let's try guessing. So we have the coefficient of 2, so this must be 2x times x. And the question is, what times what is 12? Let's try 3 and 4. We have 8 and 3 makes 5, so we got lucky. So let's try positive 8, because 4 times 2x is 8x, and a minus 3. 8x minus 3x is 5x, and negative 3 times 4 is negative 12. So we factored this trinomial. So this is the fully factored form. So let's try factoring this trinomial. Now this coefficient is quite large. It's hard to guess. So let's use this more relaxing rainbow method by multiplying this number 10 times negative 21. We have x squared plus 29x. We multiply these numbers. 10 times negative 21 is negative 210. And the challenge for this rainbow method is to multiply what times what is 210 but adds to be 29. This is going to take a bit of patience. We know that 1 times 210 is 210, but they're too far apart to be 29. So let's try skipping. 2 times 105 is still too far apart. How about 3? 3 times 70 is 210-ish, but still we're too far apart. Let's double 2, so we get 4, and we can't have 105, so let's cancel that idea. Now what about 5? Does 5 fit into 210? We know that if there's a 10 here, it's going to be 10 times 21 would be 210. What about half of 10, which is 5? So we double 21, which is 42. And the question is, do 5 and 42 make 29? We're not quite there yet. So let's try 6. Let's double the 3. We got a 6, so we have 70, which is 35. And I think we might have found it. Let's try 6 and 35. And the challenge is positive 29, so we'll put a plus sign there and a minus sign here. This times this is indeed correct. It's 210-ish, and they add to be 29. And we divide by the coefficient 10. Let's reduce and simplify. Divide top and bottom by 2. We have 3 over 5. And let's divide top and bottom by 5. We have 7 over 2. And we'll promote the denominators. So we get 5x minus 3 and 2x plus 7 as the fully factored form. When factoring, always pull out the GCF. In this case, the GCF is x minus 1. This times what becomes the first entire term? It's x squared. X minus 1 times what becomes the second term? It's plus 4. So when we use distribution, we get the two terms above. Now we can no longer factor x squared plus 4. We're done. So this here is the fully factored form. Let's try factoring this expression. Notice how we have a GCF. It's just hidden. The x minus 2 and the 2 minus x looks awfully familiar. Let's rewrite this as, instead of plus, minus. And when we distribute minus to the negative x, we switch the signs from negative to positive, and the positive 2 becomes a minus. When we distribute the negative 1, it becomes the same expression as the one above. And this 9, we're allowed to move it to the left as well. So we write x squared, x minus 2, minus 9, x minus 2. And we'll now factor out the GCF, x minus 2. So we now have x squared minus 9. We're just going to throw these in here. And when we use distribution, this times this times this, we realize we have the same expression above. But we're not done yet. We need to factor fully. So we use difference of squares. X plus 3, x minus 3 is x squared minus 9. So we now have the fully factored form.